Now using binomial table, even for a relatively small value of n, the computation of binomial probability can be tedious. That means it is very difficult to find if even if the value of n is very small. See, for example, if given n is equal to if it's equal to 20, that means x can choose the values 0, 1, 2, etc. up to 20. Now, if the question is what is the probability of at least 10 success, probability of at least 10 success, that means probability of the random variable x takes the value greater than or equal to 10. So 10 success, at least 10 success. So the possibility of x's are 10 success, 11, 12 success, 13 success, etc. up to 20 success. That means P of 10 plus, P of 11 plus, etc. up to P of 20. So 11 terms are there. So we have to calculate each 11 terms separately. P of 10, that means B of binomial of x is equal to 10, n is equal to 20, P is equal to, so P probability of success, say small letter p. So we have to find this value. This is equal to P of 10. N, that is 20, C 10, P raised to 10, Q raised to 20 minus 10, that is 10, plus P of, so this is P of 10 plus P of 11. Similarly, we have to find P of 11, that means 20C11, P raised to 11, Q raised to 9, plus 20C12, P raised to 12, Q raised to 20 minus 12, that means 8, plus up to 20. So it's very difficult to find those values, very difficult. So in this case, we'll use binomial table instead, binomial table. So binomial table, it's another notation, capital B of x n p denote sum of all probability less than or equal to x, or P of capital X less than or equal to x. Probability of the random variable x less than or equal to x. That is sum of all probability, binomial distributions, binomial probability less than or equal to x. Sum of all probability. So y is starting from 0 to up to x. So in this case, in the previous case, this one, P of 10 plus up to 20. So this is can be calculated by using the table. This is P of x greater than or equal to 10, which is equal to P of 1 minus P of x less than or equal to 10, less than 9, less than or equal to 9, or simply less than 10. P of 0 plus up to P of 10, up to P of 10, excluding P of 10, P of up to 9. So it's this probability P of x less than or equal to 9 can be calculated by using table. So it's very easy to find the value. Very easy. P of equal to 1 minus P of x less than or equal to 9. So this can be calculated by using table. We can just, all we have to do is just replace the value using table. We'll get the solution. So the capital B x n p denote sum of all probability less than or equal to x. See, for example, suppose that 20% of all copies of a particular textbook fail a certain binding strength test. So 20% of copies of a particular textbook fail a certain binding strength. So in this case, probability of success equal to 20%. That means 0.2. So success in this case, success is textbook fails a certain binding strength test. Strength test. Failing strength test is the success. That means probability of success is equal to 0.2. Now let capital X denote the number of among 15 randomly 15 randomly selected copies that fails the test. So X is equal to N is equal to 15. Then capital X has a binomial distribution which N is equal to 15 and P is equal to 0.2. Now the probability that at most 8 fails the test. Probability of at most 8 textbook fails the test. P of X less than or equal to 8. Equal to, so this is equal to P of 0 plus etc. up to P of 8. Using binomial table, so this is B of small letter b of 0, comma, N is equal to 15, P is equal to probability of success 0.2 plus binomial of 1, comma, 15, comma, 0.2 plus etc. up to the last one B of 8, 15, 0.2. This is equal to sum of all probability 0 to 8 B of y equal to 0 to 8 y comma 15 0.2. So this is cumulative distribution function. Cumulative distribution function of binomial distribution function. So this is can be calculated by using the table. So using binomial table, the value of capital B 15 0.2. So capital B of 8 15 0.2 is equal to, so this is the binomial table for n equal to 15. N equal to 15. P value, probability value 0.2. 0.2 x values. X can choose 0 up to 15. X equal to 8. X equal to 8. P is equal to 0.2. So this is the value. Probability. Sum of all probability less than or equal to 8 is equal to 0.999. 0.999. Next question. The probability that exactly 8 fails. Probability that exactly 8 fails. That means probability of P of capital X takes the value 8. So there are two methods we can find this value, that means using the direct substitution, that is NCX P raised to X Q raised to N minus X. N is equal to 20, N is equal to 20, X equal to 8, so 20 C B of x equal to 8, 20 x is 50, n equal to 50, 8, 15, 0 point, which is equal to NCX, n equal to 15, C8, 0.2 the whole raised to x, in Cx, p raised to x, q raised to 1 minus 0.2 the whole raised to 8 minus 15 minus 8 equal to 7. So find the value, calculate the value using calculator, you can find the value. Or another method of finding this value using binomial table, you need to find small letter b of binomial of 8, 15, 0.2. Now capital B of 8, 15, 0.2 is equal to probability of x is than or equal to 8. So first we will find the probability of x less than or equal to 8. Then capital B of 7, 15, 0.2 equal to probability of x less than or equal to 7. So sum of all probability less than or equal to 8, sum of all probability less than or equal to 7. So this one minus this one will get the probability of x takes the value exactly 8. Sum of all probability less than or equal to 8 minus sum of all probability less than or equal to 7. So P of x less than or equal to 8 minus P of x less than or equal to 7 is equal to P of x equal to 8. Now the probability, sum of all probability capital B of sum of all probability less than or equal to 8 equal to capital B of 8, 15, 0.2. Using table probability capital B, x equal to 8, n equal to 15, p is equal to 0.2. So already previous question we have we found the answer 0.999 is the solution. 0.999. Now capital B of 7, 15, 0.2. Using the table, x equal to 7, p is equal to 0.2, value is 0.996. 0.996. Now subtract these two values, you'll get the exact solution. Binomial of B of 8, 15, 0.2 is equal to 0.999 minus 0.996, which is equal to 0.003. 0.003. So this is the probability of the value. Probability of the random variable x takes the value 8. Another one, probability of at least 8 fails. At least 8 fails. At least 8. Probability of x less than or equal to at least 8. x greater than or equal to 8. Probability of x greater than or equal to 8, which is equal to 1 minus p of x less than or equal to 7, which is equal to 1 minus p of x less than or equal to 7, that is capital B of cumulative distribution function, sum of all probabilities up to 7. Capital B of x equal to 7, 15.2 equal to 1 minus capital B of 7, 15, 0.2 equal to 0.996. 0.996, which is equal to 0.004. X equal to 7, P is equal to 0.996. So the final value 0.004. Now, finally, another example. Probability that between 7 and 4 and 7, between 7 and 4, P of 4 less than or equal to capital X random variable less than or equal to 7. So which is equal to, this is equal to capital P of X less than or equal to 7, sum of all probability less than or equal to 7 minus sum of all probability capital P X less than or equal to 3. Sum of all probability, this is nothing but P of 4 plus P of 5 plus P of 6 plus P of 7. Now P of x less than or equal to 7 is equal to P of 0 plus 1 plus 2 plus P of 3 plus P of 4 plus up to 7, P of 7 minus P of 0 plus P of 2 plus 1 plus P of 1, 2 plus P of 3. 0 to 7 minus 0 to 3 equal to 4 to 7. 4 to 7. So this is can be calculated by using the table. This is also can be using calculated by using the table. So this is equal to capital B of equal to capital B of x equal to 15, x equal to 7, x equal to 7, n equal to 15, 0.2 minus capital B of 3, n equal to 3, x equal to 3, n equal to 15, 0.2, which is equal to, so this is already we have calculated, which is the value is equal to 0.999, and this one P is equal to 3, n equal to 15, P equal to 0.2, n equal x equal to 3, x equal to 3, P equal to 0.2. So the value is 0.648, 0.648, 0.648. So the final solution is equal to 0.348. So this is the probability of x between 4 and 7. Between 4 and 7. Now mean and variance of a binomial distribution. Mean of a binomial distribution is equal to expectation of x, which is equal to n into p. Variance of x is equal to n into p into 1 minus n into p into 1 minus p, or simply npq. Variance is equal to npq, mean equal to np for a binomial distribution. The standard deviation is equal to root of npq. Q is equal to 1 minus P, probability of failure.